Hello, in this video I'm going to answer a few questions in the book Advanced Engineering Mathematics 2nd edition by Wiley. So the first question is found in page 28, number 12. So, which is x dx squared plus y dx is equals to y dy. So in the solution, first we need to put all terms of x in one side of the equation and y on the other side. So we will divide e to the y on both sides. The x part is easy to integrate, but the y part needs to be integrated by parts. So we need to let u is equals to y, and therefore du is equals to dy, and dv is equals to e to the negative y dy. Therefore v is equals to negative e to the negative y. Therefore, in the equation uv minus v du, we will get negative y e to the negative y minus the integral of e to the negative y dy. Therefore, then we get the negative y e to the negative y minus e to the negative y plus c. Substituting to the original equation, we will get a constant equals y e to the negative y minus e to the negative y minus 1/2 e to the x squared. So the next problem is found on page 35, number 5, which is x squared dy plus 2xy minus x plus 1 dx is equals to 0. So in the solution, first we will transpose this equation to the other side of the equation to form x squared y over dx. Then we will divide both sides by 1 over x squared to obtain a linear equation dy over dx plus 2 over xy is equal to 1 over x plus 2x squared. So by obtaining this equation, we will get an integrating factor v, which is equal to x squared. So we will multiply the integrating factor to both sides of the equation, then we will obtain an equation d, which is y dot x squared is equal to the integral of 1 over x plus 1 over x squared multiplied by x squared dx. So by integrating, we will get y is equals to 1/2 minus 1 over x minus c over x squared. Then in page 38, number 9, the problem is yx dy plus y squared plus 2x squared plus 2 dx is equals to 0. Then in the solution, just like the previous example, we will transpose this equation to the other side to obtain yx dy over dx. Then by multiplying both sides of the equation by 1 over yx, we will obtain dy over dx plus y over x is equal to negative 2x squared minus 2 over yx. So this is a special type of integration called the Bernoulli equation. So in order to integrate this equation, we will let u is equal to y1 minus n, where n in this equation and in this problem is equal to negative 1. Therefore u is equal to y squared. Then du over dx is equal to 2y dy over dx. Then by substituting this to the original equation, we will obtain du over dx plus 1 over x y squared is equal to negative 4x squared minus 4 over x. But we know that u is equal and y squared is equal to u. Therefore, du plus 2 over x u is equal to negative 4x squared minus 4x. Then we will obtain an integrating factor v is equal to x squared. Therefore, du dot x squared is equal to the integral negative 4x squared minus 4 over x times 4x times x squared du. Then by integration, we will obtain u dot x squared is equal to negative x to the 4 minus 2x squared plus c. But since u is equal to y squared, we will obtain the equation y squared x squared plus 4x plus x to the 4 plus 2x squared is equal to c. On page 64, number 99, we will get an application of differential equations where the question is: one winter morning it began snowing heavily and continued at a constant rate every day. At noon, a snowplow able to clear 6 feet cube per hour of snow with a blade W feet in width started plowing. At 1 p.m. it had gone 2 miles, and at 2 p.m. it had gone another 1 mile more. When did it start snowing? Hint: T sub 0 is the number of hours before noon when it began to snow. If T is the time measured hours after noon, if S feet per hour is the constant rate at which the snow is falling, if Yt is the depth of the snow measured in feet, and if Xt is the distance of the snowplow has traveled measured in feet, then Y is equals to S T sub 0 plus T, and Wy dx is equals to C dt. In order to solve this problem, we will look at its given. C is the amount of the snowplow can clear in feet cube per hour. W, the width of the snowplow's blade in feet. T sub 0, the number of hours before noon when it started to snow. T, the time after noon when the snowplow started blowing. S, the constant rate at which the snow is falling in feet per hour. Yt, the depth of the snow. Xt, the distance traveled by the snowplow. At 1 p.m. the snowplow traveled 2 miles. At 2 p.m. the snowplow traveled 3 miles. And the equation y is equals to S T sub 0 plus T, and Wy dx is equals to C dt. So using the equation Wy dx equals to C dt, we can integrate both sides to get x t is equals to C over Ws ln T sub 0 plus T plus C, and making t equals to 0, xt is also equal to 0. Therefore, we can get c is equals to negative c over Ws ln T sub 0. So therefore, the equation became xt is equals to c over Ws ln T sub 0 plus t minus c over Ws ln T sub 0. So at t equals 1 hour, xt is equals to 2 miles. Therefore, 2 is equals to c over Ws ln T sub 0 plus 1 over T sub 0. And also at t is equals to 2 hours, xt is equals to 3 miles, where 3 is equals to c over Ws ln T sub 0 plus 2 over T sub 0. So this equation can be written by c over Ws is equals to 2 ln T sub 0 plus 1 over T sub 0. And in the other side, c over Ws is equals to 3 ln T sub 0 plus 2 over T sub 0. So we will get E 2 ln T sub 0 plus 2 over T sub 0 is equals to E3 ln T sub 0 plus 1 over T sub 0. So the equation became T sub 0 plus 2 over T sub 0 squared is equals to T sub 0 plus 1 over T sub 0 cube. So by manipulation, we obtain T sub 0 plus T sub 8 t sub 0 squared plus t sub 0 minus 1 is equals to 0. So using quadratic formula, we can obtain t sub 0, which is equal to approximately 0.618 hours or negative 1.618 hours. But since t sub 0 cannot be 0, then t sub 0 is equals to 0.618 hours. So the snow started at 0.618 hours or approximately 37 minutes before noon at 11:23 a.m.